So, as Jarek said, today I will talk about secret management and in particular use case within serverless applications. So maybe let's start with a question why I choose that topic and why I decided to present that today. So there were three things that inspired me to do this session. First, I was recently on few meetups in Krakow where I live, and there was in couloirs there was a lot of discussion. Well, within the developers and architects, how actually stored secrets in cloud. And I was a bit surprised that there was some confusion how we can actually approach that. And a few weeks later, actually, I had the same discussion in my at my work, where developers came to me and asked the same question. Well, we need to access some database. From where we can get the secret? Yeah, so that's I wanted to talk about today with you. I also unfortunately seen in some projects years ago and during my whole career that API keys or passwords or any other secrets are sometimes stored in plain text in Git and shared via Slack and so on. So that I want to address today. So after that session, I would like to be sure that nobody actually stores secret, the very important secret in a configuration file, that they are not encrypted in plain text and so on. Maybe let's start with a question, why to encrypt that. I hope I don't have to spend a lot of time explaining why, but just a few examples. Of course, famous GDPR and leakage of our data and $20 million that we can pay and so on if somebody will get to our data that we are processing. But I wanted to talk about two other cases. First is that actually your business can go bankrupt if you put wrong strings in wrong place. So there is an example from CodeSpace. They were some kind of service provider, and they pasted API keys to the AWS console into GitHub, public one, unfortunately, and they had backups and everything, but everything was erased because the backups were in the same AWS account and so on. And well, they are closed right now. That's the one thing. And from my personal kind of experience, actually from one guy that I met in some AWS training, he did the same thing. By mistake, he pasted AWS key for AWS account into public GitHub just by mistake. He had configured alerts to notify him when he reached certain limit of dollars spent, but it was in the evening, and unfortunately in the morning, there was $2,000 spent already, because there are some bots on the internet that are searching through GitHub, looking for those API keys, and they are spinning basically EC2 instances to do cryptocurrency mining. So in the end, the story is not that bad, because he wrote to AWS and AWS canceled this bill, but well, we don't want to end up with that. So who am I? I'm a cloud solution architect working at Grand Parade. I'm focused on public and private clouds, as also Jarek said. You can find me on LinkedIn, and I'm sometimes blogging on Cloud Well Served. So let's start with a simple question. Who knows what is Aws Lambda? Okay, many of you, but not everyone. So I will start explaining. So AWS Lambda is basically a serverless compute offer from AWS. You can run inside Lambda any code that you want. It's like a function that will perform this code, and without worrying about underlying infrastructure, like no spinning any virtual machines or anything like that. So there are certain use case that though this Lambda has to access some services, like for example AWS services, maybe database, or some external services where there are API keys needed to access that service. So I will again talk maybe about use case from my work life. So we have I'm working in a trading where we are taking a lot of data about sport events. Yes, because we are enabling customer to gamble on that events if somebody wins or lose or something like that. So we have to process a lot of data in almost real time, I would say. So to do that, we use different services, but for some cases we use Lambda that actually gets the data from external data providers and then transform it or store it in some databases or some storages, like for example relational database. So before I will go into the details how we can solve a problem with secret management, let's think first what is a good secret management solution? What are the concerns and the design decisions that we have to make before we will choose that solution? First of all, well, we should encrypt, of course, those secrets. So encryption at rest and encryption in transit, that's a must. Then fine-grained access control, so that we can limit who can access those secrets if needed. And we need to know actually if somebody accessed them, so we have to have some kind of logs, right? Then there is also a case how often those secrets are changed. So if they are changed, if somebody leaves the company and he knows the secrets, should he know the secret, right? And so on. So the life cycle of a secret. Then, of course, costs. So if we are introducing a new solution, we also always should think about how costly it is. In small cases, maybe it doesn't matter, but if we have thousands of secrets and the process is huge, then there is this is a concern for us. Also, we have to, in this scenario, take care about scalability and availability of that service. We don't want to break our application because our key vault will break, right? And of course, the last part is the operational part. So somebody has to then operate the solution, maybe implement. So how easy is it to implement? How easy is it to operate, and so on. Okay, so we know what is a good solution for storing. How should a good solution for storing secret look like? So I will tell you about few examples from AWS world. Of course, I will not cover everything, or just a small part. And the use case that I will talk will be easy, but will prove my point. So from Lambda, I want to access my database. It will be RDS, relational database from AWS. Also, as a requirement, I want to use managed solution. So there was a talk about HashiCorp Vault or other solutions. I will focus rather on AWS way how we can do it with totally managed approach, as I have like serverless application and so on. So I'm not saying that the other things are bad, but just what I wanted to show is related to what AWS offers. Question, who heard about Terraform? Most of you, that's perfect. So this was also on the previous sessions. This is infrastructure as a code tool that we can use. Don't worry, I will show you just some really small pieces in Terraform and in Python to show my example. Okay, so let's go back to our use case. So we want to access database from Lambda function. In AWS, the first answer to that problem should be always use IAM role. IAM role is a construct that you can assign to Lambda that will give some permissions that will be associated with that role. So, for example, this can be a policy that will allow the Lambda function, this Lambda function, to access the database, right? And how it works behind the scene. So there is another service that is involved. That's AWS IAM that will generate a temporary token for us behind the scene, and basically Lambda requests for that token, gets the token, and based on that token can authenticate to database. Okay, so as I promised, a bit of Terraform code. This is just the definition of RDS instance. One thing that we have to be aware that is we need to enable IAM database authentication. It's an extension to RDS engine or to Postgres or MySQL engine. And then we can create a user that will allow access using IAM role. So that's a simple query that we have to run on Postgres, create user, in our example, DB user X, and grant RDS IAM role. This is in a Postgres world. Okay, so we have a RDS instance, so database. We have a user in that database, and now we have to have a policy that will allow accessing that database. So we just create a policy that we will assign to IAM role that it's assumed by Lambda. And in this policy, we are saying, okay, you can DB connect allow to particular resource, in our example, DB user X. And then, well, from the code, from Lambda codes, we can create this token by generating authentication token just using this username without any secret, any password to the database. And then we can use that token to actually connect to the database and sending this token as a password in the connection string. That's it. Is there any trick? Somebody noticed that something doesn't make sense here. Well, like one thing probably I skipped. I have a t-shirt who will answer that question. Do I need any password or any username to do something like that? Yes, that's the one thing, but besides that, well, sorry? I passed the username. I didn't pass the password, I generate the token. But if you didn't notice, I created IAM database with a password. Why it's like that? Well, because this is a master password that is necessary during the creation of the database. So I need to have this this credentials there before I will create the this DB user X that can use IAM role. So then there is another problem. I said that you can run just simple SQL query to create this DB user X. So how I will connect to the database to run that query? Because this is needed to even start using IAM role. Well, I have to have some kind of password and maybe use master account or some other credentials that will allow me to connect to the database and create IAM user. So what I could do to solve that problem? Well, I could, for example, create a password or generate a password in Terraform stored in my tfvars files, and then put it into git ignore that it won't be sent to Git. And then if I would need to use that credentials inside Lambda, I can pass those credentials to Lambda using environment variables. Environment variables for Lambda are like key value pairs that you can send to your function, and then you can use it inside your code. But with that approach, we can, as you can see in this Terraform example, well, we can send a password as our variable that we created before in tfvars in Terraform. It won't be in Git. That's good, right? Not maybe entirely, because there are two things. First, this password will be stored in a state file in our Terraform state, right? And unfortunately, well, first maybe I will explain what is the Terraform state for who you don't know. So Terraform state gathers the configuration for the real environment, and every option that you configured in Terraform will be in that file. So even if you not putting this password into Git, this still will end up in the Terraform state file. This can be solved, for example, if we have a remote state with storing this state in some secret place, let's say. For example, in S3 bucket, where we have this bucket encrypted and so on. So it's not it could not be that big issue, but definitely sending this password inside environment variables into Lambda, then it's a issue, because everyone who has access to configuration, even read-only configuration of that file, will see that password that we sent, plain text, as you can see. As you can see on the screen. Okay, so actually now we are going to our first solution, how we could store those secrets in our example. So there is a AWS service, key management service, that will allow you to encrypt and decrypt for example, strings, so any secret. So what we can do is basically first encrypt that secret using KMS, then put the encrypted variable inside Terraform, and during the provisioning, the Terraform will put it into environment variable for Lambda, so inside the code we can get still the encrypted secret, and then we can use IAM role to access KMS to decrypt the secret in runtime. So That's how it could work. So let's go through some quick example how we actually could type it. First, we need a key. So this is AWS CLI, simple commands that will generate, first one, they will generate a key for us. Then in response, we will get the key ID, and we can use AWS KMS encrypt, and with that key that we generated to encrypt any secret that we want to be encrypted. And this encrypted secret we can put into environment variables, and it won't be visible as a plain text inside our configuration. It will be some encrypted string. And then inside the code, well, as I mentioned, we can basically decrypt the secret using IAM role, and we have simple, this is a simple Python code that does it, just a decrypt method that will get the password, the secret, the password for us. So there are some pros and cons of that approach. So first, the pro is, of course, there is no plain text. There is no plain text, but the plain text exists somewhere, and the user knows the plain text because he created. It can be done otherwise, but in our example, user created the secret, the password for the database in this example, and he knows it, and then he encrypts it, and Lambda decrypts it. So yeah, no plain text, but actually the plain text somewhere exists. And another pro from my perspective is that KMS is quite cheap. So we have just $1 per key. So not per secret that we decrypt, but per key that we will use for encryption. Good practice would be to use one key per application, or maybe for some part of the application, of course. And just 3 cents for 10,000 requests to the service, so decrypts, encrypts, and so on. There are some downsides, of course. First, and the biggest, I would say, is that the secret is updated during the deployment of Lambda function. So this was mentioned on the first presentation today. So what happens when we want to change our secret? Well, we have to redeploy the Lambda function at least, or change the environment variable somehow, because this is during the deployment of the Lambda, not during the runtime. And there is no automated rotation of that secret. So if we want to change every 7 days, let's say, this password or API key to some external service, we have to write this automation by ourselves. So let's take a look on the second approach within AWS, how we could store those secrets. So there is another service. It's a part of System Manager service. It's called Parameter Store. This is kind of Key Vault AWS offering that can store keys for us. So how then our solution would look like? Well, we will generate automatically this secret in Terraform, update during the deployment parameter store, and then during the runtime, Lambda can, based on IAM role, get the secret from parameter store without any password based on that IAM role that I was mentioning, right? So, okay, let's take a look. We can generate this string, for example, using resource random string from Terraform. We'll get 16-digit string, and then we can just in a value of SSM parameter resource put that string. Pretty simple, and then from Lambda code, we want to get the secret. So again, using IAM role assigned to that lambda, we can just we just need a name of that secret. So name of that secret can be passed to lambda using environment variables, and then we can get parameter method to, based on that name, basically get the secret. Again, pros and cons. So the biggest pro for me is it's totally for free. You don't have to pay for anything, for any API calls, for anything, for storing those secrets. It's totally free. With one caveat, with the standard version. And what the standard version means, I will explain. And the second advantage is that secrets are read during the runtime, as I mentioned, right? So the downsides could be that secrets are still visible in the Terraform state in our example, because we are generating them in a Terraform. Then the biggest, for some use cases, the biggest minus could be that we have low throttling limit. It means the standard version can do only 40 decrypts per second. So in our scenario, we hit that limit in my work, because we have multiple lambdas running concurrently with from multiple applications, and they were trying to get the parameter, the password or whatever API key we have from the parameter store, and we reached that 40 decrypts per second. So we can avoid that by using paid version. There is where we can extend the 40 decrypts per second limit, but again, it depends on use case. I like this parameter store because it's free. One thing is missing here still is no rotation of the secrets. So if we want to rotate the secret, we can, of course, but if we want to change secret for the database that I was mentioning, well, we have to write probably some kind of script, Lambda or whatever, that will update the secret inside RDS and then update parameter store. We don't have to redeploy Lambda because Lambda will take it in real time, but still this is a piece of code that we have to do. So the third solution that we could use, there was also, it was mentioned on some previous sessions, Aws Secret Manager. There is another managed service that AWS offers that could do this for us. This works pretty much the same as parameter store, so we can store some secrets. We can use Terraform to update that secret manager. We can use IAM role with Lambda to get the secret. But the one thing or one of the features from Secret Manager is that it automatically rotates your passwords for some AWS services. For example, for RDS, it does it out of the box. We don't have to, we just need to configure it. I will show you how. So again, we can generate some kind of random string, and then we have to create a vault and a secret within that vault. You can see that in that example. So we are creating vault using KMS actually in the background to decrypt all secrets that we will store there, and then we are creating a secret within that vault that will hold our password. And interesting part is here is that there is a rotation lambda. So as I said, AWS provides you a rotation lambda, so piece of code that will change passwords in RDS out of the box. If there are some services that are not supported, you can write this lambda by yourself, but that's good that this secret manager allows to do that. And then we have a rotation policy for, in this case, for 7 days. So every 7 days, password will be rotated inside RDS. Worth to notice is that the first time when the password will be rotated is just on the beginning when we create that policy. So it means that actually even if we create a password inside Terraform, well, it doesn't matter because it will change in a second. Okay, and the last part is the same, almost the same as before. We can, from Lambda code, get the password and use it if necessary to in our connection string to the database. Okay, so again, pros and cons. The pro is, again, secrets are loaded during running of the Lambda, so not before. And the biggest one is for me that those secrets are generated and rotated out of the box. And this is really scalable solution. So do you remember the limit, like 40 decrypts in parameter store? It doesn't apply here. We have out of the box 1,500 API calls to Secret Manager. That's the limit, but we can raise it if necessary. Just contacting AWS, we can easily do it. But that's a pretty huge number, I would say. But there are also some downsides, of course, because, well, we have to pay for that. And depends on the scale, but it can be a huge amount of money. So it's 5 cents per 10,000 API calls, but it's 40 cents per secret per month. So per secrets. If you have thousands of secrets, then, well, it can be costly. So we have to think if it's worth it. Yeah, and again, this is just like a whole summary what I just said. Those three solutions, every one of them actually encrypts our secrets. Every one of them can be used to see who accessed those secrets, because we have AWS CloudTrail service that actually logging what we are doing. We have fine-grained access control with IAM roles to access those services, simple. And then the scalability part that I mentioned already. But with KMS, we don't have a problem, I would say, because this is like 10,000 keys that we can generate out of the box. So not secrets, but keys that will be used to encrypt the crypt. And but we have to pay for each key. And the biggest advantages for me for parameter store is that it's free, and for Secret Manager, well, we have to pay, but we have more scalable and more robust solution, because also of that rotation of the secret that I was mentioning, and also generation. So we don't have to generate it by ourselves. We can just call Secret Manager to generate the secret for us. We'll know ever what the secret was. So that's it. I have just one favor to ask in the end. So if you still somewhere store your secrets to crucial services in plain text, just check it if they are there and change it. Okay, thanks.